Okay, so the last thing that we kind of add on to this is we can think about mechanical energy. So to calculate mechanical energy is just finding the total kinetic energy in all forms of potential energy. So this isn't change in potential or kinetic. This is just the kinetic energy and potential energy at a moment, at a spot. Okay? So this is not change. Okay? So this is not delta. It's at one spot or time. Okay, so you're looking just the mechanical energy at a place in time, at that spot. Okay. The other things are about changes. So just kind of make that distinction. So an example, a cannon is fired from Earth's surface. At the peak of its trajectory, it has a horizontal speed of 160 meters per second, and it is 1.2 times 10 to the 3 meters above the ground. With reference to the ground, what is the mechanical energy of the cannonball at the highest point? So it's asking us at that moment in time, at that spot, how much mechanical energy does the cannonball have? Okay? So we don't do any deltas, no changes. So let's just draw a picture so that we have this conceptualized. So here's our cannon, shooting it. So it's asking us at its height here, okay? This is where our V is, and the height it gave us is this height here, okay? So we're talking at a moment in time, what is EM? Mechanical energy at that spot. So I know my V, I know my H, I also know my M, 5.2 kilograms, and I know my G. It's always the same when on Earth. So EM is equal to EK plus EP. So that's half mv squared plus m times g times h. Now this is not where you cross off m's. Before in another unit where we got to cross off m's, that was only because m was on both sides of the equal sign. So don't get excited and start crossing things off. Okay? So let's put in all the things we know. 5.2 kilograms times by 160 meters per second squared plus 5.2 kilograms times by 9.81 meters per second squared times by 1.2 times 10 to the 3 meters. One, 2, 7, 7, 7, 4.4. So to save things, mechanical energy is 1.28 times 10 to the 5 joules. Okay, so questions on page 308 and 309. So the yellow box practice problem. So 1 to 3 and then 1 to 3. So again, as I said, the example that I did for the most complex work one is the same one as in the textbook, and then the cannonball one is right here too.
For the number 3, for your equation,